All right, Unit 8. So we'll start with 131. They tell us that WT remember, we care about units, so they tell us it's cups per day. So I'm going to make note of that. And it wants to know the average, that word's very important, amount of water he drank. So basically what we need to do, if we want to know the average amount, we have to take the antiderivative of W of t dt. Then if I want the average, notice they tell us it's from 0 to 4. So I need to multiply this by 1 over 4 minus 0, just because that's our average function formula that we use. Now, I know I'm very big on looking at units here, so let's think about this. W of t, if I take the antiderivative of cups per day, we're going to go back a rate, which just makes this cups. So you're probably thinking, how is this in cups per day? Well, this 1 over 4 minus 0 is 1 over days. So if you multiply 1 over days times cups, you get cups per day, which makes our answer to this one A. So if it ever asks for the average amount, do 1 over B minus A, multiply by the antiderivative of your rate. 132 is another average value. So right away we should just set up our antiderivative. So it's 1 over 4 minus negative 1. The integral from negative 1 to 4 of our function. And I'm just going to do this like a normal problem. So obviously 1 over 4 minus negative 1 is just 1 over 5. And then I'm going to take that antiderivative. So I get x cubed over 3 minus x squared over 2 minus 2x. That gets evaluated from negative 1 to 4. So now we just got a lot of math. It's going to be 1/5. Then I'll plug in a 4, so 4 cubed over 3 minus 4 squared over 2 minus 2 times 4, all minus 1 cubed over 3 minus 1 squared over 2 minus 2 times 1. So now I just need to start thinking about what each of this equals. So 4 cubed is going to be 64 divided by 3. So I have 1/5, 64 thirds, minus 16 halves, minus 8. Actually, yeah, I'm not doing this. You can put this in your calculator. If it came to the real test, I'm just going to trust that you remember how to do fractions. But I don't feel like doing it. The answer is B, though. Hopefully they give you a calculator for that. All right, 133. They give us our acceleration, and they want a position. So I know if I'm going from acceleration, I want to get to velocity. I take the antiderivative. Which tells me velocity here is going to be t cubed over 3 plus c. And then this line here, at time equals 0, the velocity is 2. So 2 equals 0 cubed over 3 plus c. So 2 equals c. So my final velocity equation here is t cubed over 3 plus 2. But to get my position, I take the antiderivative again. So I end up with position equals t to the 4th over 3 times 4, which is 12, plus 2t plus c. And they tell us the position is -3 at 0. So -3 equals 0 plus 0 plus c. So basically c is -3. So our position has to be t to the 4th over 12 plus 2t minus 3, which gives us A. All right, 134 is asking us about which of the following expressions does not represent the total distance traveled. So when you think of total distance traveled, you should be thinking of an absolute value. So we know it's going to be some sort of absolute value of velocity, but the integral. So looking at these, A is the normal way you'll see it. So it's not A. B is wrong. The reason why B is wrong is because you never put absolute value on the outside. That's weird. It's not right. And then C is fine. They just broke up our integral into 2 separate ones. That's still the same. And then D is right because it tells us that basically it's following when it's positive and negative. That's why we subtracted it from B to C. So D is still correct. Absolute values on the outside. On B though, it's weird. Not right. All right, 135. So velocity is given by cosine. Total distance traveled from 0 to 2 pi. So from 0 to 2 pi. Total distance, remember, is absolute value. So I need absolute value of cosine t dt. And honestly, if this is not a calculator question, just skip it because y'all don't know your unit circle. And honestly, it took me forever to do it by hand. But when you put this in your calculator, you should get 4 or D. All right, 136, particle, blah, blah, blah. Average acceleration of the particle. So average acceleration, this is another average value. We have the function for acceleration because they tell us a of t equals 3t. So anytime you see that word average, you should be thinking 1 over b minus a, in this case 4 minus 0. Then our integral from 0 to 4 of 3t dt. Now this one actually looks doable to do by hand, so we have 1 over 4. Our antiderivative is 3t squared over 2. And we're going to evaluate that from 0 to 4. So 1/4, 3 times 4 squared over 2 minus 3 times 0 squared over 2. So that's just going to be because 0, we don't really have to worry about it. This one we have 16 divided by 2 is 8, so times 3, sorry, I don't know, I can't think. This is going to equal 24. And then we have 1/4 of 24, which equals 6. So our answer is B. That's more the type that I would expect you to have to do by hand. 137, we're back to Riemann sums. What is the approximation of the average velocity from 0 to 10? So average, once again, you need that function we've been talking about. So what we're going to approximate here is 1 over 10 minus 0, so 10. 0 to 10 of velocity. And we're approximating this with a left Riemann sum. So I'm going to start at the left. So I'm going to really have 1 over 10. 4 times my change of 2 plus 6 times my change of 2 plus 3 times my change of 3, 1 times change of 3. So if I do the math here, I'm going to end up with 8 plus 12 is 20, plus 9 is 29, plus 3 is 32. So 32 over 10, which equals 3.2, or C. (138), we're talking about total amount of t at 6 hours. But the important thing to remember here, they tell us at t equals 0, there are 10 gallons in the machine. So before we're even starting, we have 10 gallons. And then I need to take 0 to 6 because R is in gallons per hour, so I need to take the antiderivative of that. And that should give you the total amount of t. So B. If we're going to look at what's wrong with each of these, A doesn't take into account the 10 that was already there. C is a rate, so they took the derivative, which would make it gallons per hour. Taking the antiderivative of that would give us gallons per hour. And that does not tell us the total amount of t. So not C, not D. All right, 139. So this is one, let's write down what everything means. So d of t is the rate it's dispensed. And then E of t is the rate that is eaten. Both of these pounds per minute. So if I want to know the amount of change in food from 1 to 6 minutes, obviously I need an integral from 1 to 6. And then let's just think about this. The food's dispensed minus the amount the cat eats. The cat can't eat more than is dispensed, that's why it comes second. So A. The fact that it says change makes it where it can't be C and it can't be D. B just doesn't make sense because the cat would be eating more than it was dispensed. It doesn't work. All right, 140. So we have an equation about this guy's board games. And it's basically saying D of t is the rate that he donates them, B of t is the rate that he gets them. And we want to know how many he'll have after 3 years. So the fact is he has 80 to begin with. So we're going to start with an 80 minus the change from 0 to 3. And it's going to be his amount he bought minus the amount he donates. But now we actually have to solve this, so it's going to be 80 minus 0 to 3 t squared minus 3t. which is going to equal 80 minus t cubed over 3 minus 3t squared over 2, evaluated from 0 to 3. So when I plug this one in, obviously the zeros would become 0, so it's going to be 80 minus 3 cubed is 27 over 3 minus 3 times 3 squared over 2. So this is really 80 minus 9 minus 27 over 2, which is 13.5. If you calculated that, you should get 75.5. But to the nearest whole number would be A, 76. (141) is an area problem, so let's draw our picture. So we have y equals 2x, and we have x squared. And we need to know the area of R. So first off, we got to figure out where these two meet. So I need to know, when does 2x equal x squared? So I can subtract that over and factor out an x. So these two should be equal at x equals 0 and x equals 2. And then if we're unsure which one's on top, let's plug in a 1 here. So 2 times 1 is 2. 1 squared is 1. So 2x should be on top. My picture says that. And then I'm just going to do top minus bottom. So 2x minus x squared dx. Remember, area is just top minus bottom. You don't have to do anything crazy. So then I take the antiderivative. I get 2x squared over 2 minus x cubed over 3, evaluated from 0 to 2. These 2's cancel out. So I plug in a 2, I get 4 minus 2 cubed is 8 over 3. Then if I plugged in zeros, everything would become a 0. So I can change 4 to 12 thirds minus 8 thirds should give me 4 thirds, which is C. Alright, next, sine x on the interval from 0 to pi over 2. Once again, draw my picture. So sine x, thinking about what that graph looks like. Should be like this. Here's 0. Here's pi. I know we don't only need to go to pi over 2, but that's okay. Y equals 1. Is going to be up here. And then the y-axis. So that's right there. So if we think about pi over 2, sine of pi over 2 equals 1. So now I'm going to do my integral from 0 to pi over 2. And let's plug in a number in between. So let's say I plugged in pi over 3. So if I plugged in pi over 3 here to sine of pi over 3 is square root of 3 over 2, which is going to be less than 1. So 1 should really be in front here. That's on top. Minus sine x dx. And then I just need to take the antiderivative. So this is going to end up being x plus antiderivative of sine is going to be negative cosine But since it was negative sign, it's going to be plus cosine. Evaluated from 0 to pi over 2. Now I'll just plug everything in. So pi over 2 plus cosine of pi over 2 minus 0 plus cosine of 0. So cosine of pi over 2 becomes a 0. So really what I'm left with is pi over 2 minus cosine of 0 is 1, so minus 1. My answer is B. (143), another picture. Here's x equals y. And I have square root of y. So I need to figure out where these two are equal. So y equals square root of y. And notice these two are... Actually, let me not do y's. That makes this harder. I'm really just trying to figure out where does x equal x. Well, we know it's going to be at 0 and at 1. Because if I subtracted this, sorry, if I'm using x here, I have to take the square root. So it's going to be x squared equals y. I'm being dumb. So then I get everything to one side. So 0 equals x squared minus x. So that's how we get 0 and 1. I just like to use y equals equations instead of x equals because it makes it easier. That's why I changed this one. So now my integral from 0 to 1. And then top minus bottom. So if I plugged in 1/2 here, this one would be a half. This one, if I plugged in 1/2, would be a fourth. So really, we should have x minus x squared dx. So I take the antiderivative, I get x squared over 2 minus x cubed over 3, evaluated from 0 to 1. Plug it in, I'm going to get 1/2 minus 1/3. And then if I make common denominators here, so I get 3/6 minus 2/6, should end up with 1/6, or A. Alright, finally we don't have to solve these anymore, we're just setting them up. So cross-section perpendicular to the x-axis are rectangles. So here I should be thinking area equals length times width, or base times height, whatever. They tell us that our bounds are from A to B. And then it's perpendicular to the x-axis. So perpendicular to the x-axis, if you think about it, it's going to be top minus bottom. And then the fact that they tell us g of x is greater than f of x means that g of x should be on top. So my base is going to be g of x minus f of x. Then they tell us that the height is 5 times that. So times 5 times g of x minus f of x. Now obviously that's not an answer choice, but I know I can take the constant to the outside. And then I'm just left with g of x minus f of x times g of x minus f of x, which is just 5 times a to b g of x minus f of x squared. So our answer is B. This one tells us our cross sections are squares, so we should be thinking area equals side squared. And then right away you can kind of tell what your answer is. There shouldn't be a pi. And then this one doesn't have a squared, so it's not B. The answer is D. But for the same reason, A to B, our base is K of X minus P of X. And we're using our formula for a squared, so we have to square it. All right, triangles, we know it's 1/2 base times height. So I set up my integral from A to B. My base is going to be, again, h of x is greater than f of x. So h of x minus f of x. And since it's an isosceles, both sides are going to be the same. So that's going to be squared. And I just multiply it by 1/2. So thinking about this, triangles, you should not have pi's in triangles. And then this 1/2 isn't being squared because the square comes from base and height being the same. So 1/2 should be on the outside, which makes our answer D. All right, 147. This one, they tell us that it's going from A to B. Then they just tell us our area is sine of 2x. So we actually have to take the antiderivative here. So if I think about u sub, u equals 2x, du equals 2 dx, which gives me 1/2 du equals dx. So 1/2 sine of u du from A to B. And I know my antiderivative of sine is negative cosine, so it's going to be 1/2 negative cosine 2x from A to B. So 1/2 negative cosine of 2b plus cosine of 2a, or a. All right, 148. So we have a region. Let's draw it. Here's square root of x. The x-axis. X equals 4. And then they tell us it's revolved around the x-axis. So obviously I'm going to be doing a top minus bottom here. This is just going to be a disk method. So I'm going to have pi on the outside from 0 to 4, because obviously this point here is 0. This x equals 4 tell us it ends at 4. Then top minus bottom, so square root of x minus 0, because our bottom line is the x-axis, dx. And then we have to square this, because it's the radius squared. So really I'm left with pi from 0 to 4. If you square a square root, it just goes away. So I end up with x dx. So then I have pi x squared over 2 from 0 to 4. Plug it in. We end up with 4 squared over 2, which is 8. Multiply it by the pi, you get 8 pi, which is D. All right, another one we're going to draw. So I have e to the x, which is this function, x-axis, y-axis, and this line x equals 3. But we're going to rotate this around the horizontal line. Way down here, y equals negative 2. So on this one, we can tell that the function does not touch the line that it's going around. So here's where we're going to need big radius, little radius. This is going to be a washer method. So to set it up, we should have pi on the outside. We know it goes from 0 to 3 just by the numbers that they gave us. Now big radius is going to be e to the x minus -2 squared, minus little radius is just going to be the x-axis, which is y equals 0 minus -2 squared dx. So if I simplify this, I get pi from 0 to 3 e to the x plus 2 squared minus 2 squared dx. And it looks like that one's going to match C. And lastly, we have 150. Another one, just need to draw a picture. So, think here. So I have y equals x squared plus 1. It's going to be a parabola, just shift it up 1. Horizontal line, y equals 1. It's going to be here. Vertical line, x equals 2. And this is going to be revolved around the y-axis. So since we're revolving around a vertical line, I need all of my equations to be basically x equals. So if I change this one, y equals x squared plus 1 becomes y minus 1 equals x squared, to square root of y minus 1 equals x. Alright, so now we need to figure out what our y values that they are going to be. So no, this one's going to be 1. I need to find the y value where those two meet though. So when x equals 2, that should tell me y equals 5. So this point is going to be 2, 5. And I need that y value as a bound. So when I set it up, I'm going to have pi on the outside. We know it has to go from 1 to 5 because it's y values. So b and a can go away. But then we have to remember it's going to be right minus left. So looking at this, once again, our function does not completely touch this line, so it's going to be big radius minus little radius. So my big radius here is going to be the line x2 minus, this line is x equals 0, minus, the other line is square root of y minus 1 minus 0 squared dy. And we can obviously see that matches C, not D.